hope all of y'all had like safe travel and are excited for the reInvent for the rest of the week. And before we get engrossed with the great sessions that we have planned for you for the entire week, let's think through a scenario over here. You get up, you want to grab a cup of coffee. You go to your favorite coffee shop and you order your usual coffee. The barista says, "Sorry, sir, I can't do that right now. I don't have all the ingredients available at one place right now. The creamer that you like is in the side cooler. The special milk that you like is in the back warehouse, and the beans across the town altogether." Sounds absurd, right? But isn't that how organizations running our data today? That like our data sits in different systems. Customer data somewhere else. Our sales data different places. Our service analytics data completely different places. And then you have your usual questions that our executives come up with. Hey, can I know what was the sales last month? Or you know what, this new product that we launched, how is it doing based on the opportunities that we had? And it takes us weeks to get the data in the right place so that we can just run basic analysis on it. So this is why we are here. I'm Shruti Worlikar, Senior Manager, Analytics Specialist SA, and with me is Shreya Malpani, Senior Product Manager for AWS Analytics. And we have talked to hundreds of customers. And what they have told us is they wish there was an easy way to integrate data from all these different locations into a singular place. In today's session, Universal Data Connectivity with ETL and SQL queries, we'll show you how you can transform your data and make it actionable, how you can simplify the data pipelines with AWS capabilities such as AWS Glue, zero-ETL and federated query so that you can get actionable insights from it faster. We'll show you how we helped customers eliminate ETL bottlenecks, accelerate data ingestion, and maximize return on their data investments. So you're up for a ride. Quick show of hands. How many of you are using variety of operational databases and enterprise applications today and are having to stitch it together? Correct? All of us have to do that. So why is this important? This is because there is a fundamental challenge when we have to tackle all of this. In today's organization, everybody says they have to be data-driven. Now, this is not just a buzzword anymore. This is important because we need to get to actionable data faster. We need to understand what are the market changes and how do we understand our customer deeply. These all are critical for our growing our organization needs. Here is a fundamental challenge that we have. All of our data lives in different silos. The data that we have is stored in different systems or in different locations altogether, sometimes even in different cloud providers or on-premises data centers. In addition to that, we have different personas who are using this data. Now, a new trend that's accelerating right now that we are hearing from our customers is convergence of analytics and AI ML workloads on the same kind of data. So, your data scientists need access to the same data that your data analysts have, which they are using to build dashboards. The AI ML models are built on the same data that feeds into your real-time analytics systems, which makes it additionally more complex. So you might be wondering, what does this complexity look like in a real-life enterprise environment? Let's take a look at that. As you can see over here, at the bottom, we have a bunch of data sources: finance, telematics, customer experience, manufacturing, sales, product quality. Each of these systems are generating mission-critical data for our organization. In the middle, we have our data lake, which hosts the raw data sets. Then all of your structured data is sitting on your data warehouses. You are using AWS Glue Catalog to do the metadata management. You have transformation engines such as AWS Glue, AWS EMR, and then your query engines such as Redshift, Amazon Athena, and then last but not the least, you want to run ML, AI ML on top of it, so you're using AWS SageMaker or Bedrock. Now, this makes it complex. The additional piece of complexity where it comes into picture is all the different personas who are accessing these systems. Your data scientists are creating the ML models. Your data engineers are building the pipelines. Your data analysts are creating the dashboards. Your data stewards are managing the governance, and your data owners are managing access. Now, this is just one piece of the puzzle. We are not even scratching the surface about third-party data integration or even marketplace integrations. All of this makes the data jumbo more complex and more critical to navigate. We do have a solution in mind, and which we call the universal data connectivity approach. At AWS, we are taking a look at it very differently. We believe there is no one size fits all. Different scenarios require different tools, different level of controls, and different trade-offs between flexibility and simplicity. What we have built is a unified data connectivity strategy. What that means is purpose-built tools and solutions so that your user personas can utilize it for what they need at that given point of time. To make this concrete, I'll introduce to a user persona over here. One of our customers, Alex. He's a data engineer. He works for a large enterprise. He is familiar, he knows his way around ETL pipelines. He has deep Spark expertise. He can work with multiple data sources at any given point of time. But he is always struggling with similar questions. How can he drive value for his organization? How can he connect to all of these data sources seamlessly? We are talking of dozens, if not hundreds of data sources. And what tools can help him simplify this data pipeline so that he doesn't have to build deep expertise for every new tool, every new technology that he's going to use. So let's look at what Alex's environment looks like. Alex today is using Snowflake for historical data analysis for one of his use cases. The company's CRM data sits on Salesforce. The other operation data sits on SAP, and service IT data sits on ServiceNow. All of these are different disparate third-party systems. In addition to that, he has all the AWS systems that he's using. Amazon Redshift serves as his central data warehousing platform. Amazon S3 is his data lake, which is hosting raw logs or structured data that he has created, transactional data that he has created. And in addition to that, we have Amazon RDS, Amazon Aurora, which connects the operational database which are fielding or running the actual enterprise application on top. These are all different systems that the data flows through, but it needs to flow through seamlessly so that we can build in the right insights that we are looking for. So what does Alex need to accomplish with all of these different systems? Alex has 3 tasks that he has to achieve. First, creating ETL pipeline to ingest data from multiple sources. Now, all of you all are familiar with, this is bread and butter of data engineering. Extracting data from multiple sources, polishing it, transforming it into usable format, and then loading it into source destination systems. It's foundational work, but it is time consuming and complex. Second, reducing the operational load of managing the data ingestion pipelines. We talked about, right, how can he drive value faster? Every time he is building in net new applications or net new pipelines, he has to manage it. He has to fix it if something goes wrong. That is frustrating. Schema changes, add a new pipeline in, etc., etc., etc. And last but not the least, ad hoc request. We have all been in these shoes, right? Our VP comes in and we're looking for combining data across multiple different sources that he needs answers to like yesterday. We have to quickly put something together. The data analyst comes in and they are asking for access to run like a single query at one given point of time, wherein the infrastructure may not be even used at any given point of time. So these are all the tasks that Alex is struggling with today. AWS provides 3 distinct patterns to address each of these needs. Let me show you our comprehensive approach. AWS, what we call is universal connectivity options, right? So there are 3 options. Self-managed ingestion using AWS Glue connectors, managed data ingestion using AWS's zero-ETL, and in-place data access using federated queries. Each of them have their unique benefits for unique use cases. First, for teams who want control over their pipelines, they want customization, AWS Glue connectors is their go-to shop. We have built over 100 pre-built connectors for y'all to AWS and third-party applications. Managed data ingestion, if you want a pipeline but you don't want to manage the operational overhead with respect to this pipeline, with zero-ETL, you select the source, you select the destination, and AWS takes care of the managing of that entire pipeline. You don't have to worry about maintaining it or anything of that sort. And last but not the least, you have data where you need to query it on ad hoc basis, or there is data that shouldn't be duplicated across multiple systems because of security reasons, or last but not the least, you are actually combining data across multiple systems. For this, we have in-place data access using federated query. Now, each of these are available for you. Now, let's dive deep into each scenario one at a time. For the first one, we utilize AWS Glue. AWS Glue is our serverless data integration service that thousands, tens of thousands of customers are utilizing today. What makes Glue interesting? Glue is an all-in-one data integration service. You wanna manage the data quality, know what are the anomalies associated with it. You want to have the data catalog so that you can query the data. You know where the data sets are available and they are searchable. All of that is available with Glue. It's cost effective because it is serverless. No need to deploy infrastructure. You will only pay for the infrastructure that you use based on the jobs that are running. This allows you to scale from gigabytes to petabytes and only paying for what you utilize. It's tailored to support all of the data users. Your data analysts who are not used to like coding languages, they're used to more UI-based infrastructure, they can use the visual infrastructure to build pipeline without utilizing code. You have data engineers who are familiar with Python, Scala, and want to do in-depth customization. Great, they can use AWS Glue. Or you have data administrators who are actually more comfortable with SQL for you doing transformations, etc. Perfect, they can use AWS Glue too. So it gives you tailored tools for each of these different user personas. And then last but not the least, it supports all workloads in one place. Think about traditional ETL, modern ELT, streaming data ingestion or batch analytics. All of that is possible with AWS Glue. So one-stop shop for y'all. What makes this more interesting is the diversity or the depth of the platform that's made available for you. And how have we done that? We have done that with 100 plus data sources that are available for you. These are pre-built connectors that are available, which not just showcase, it's not just a number. This is years of engineering effort that's made it possible to virtually connect any source, any destination in AWS or in third-party applications available to you at your fingertips. Then we have 3 types of connectors. Native connectors. These are the ones which are managed by AWS. They are pre-built, they are maintained, they are updated. Everything is taken care by AWS for you. We have custom connectors. If you have unique requirements, if there are unique transformations that you want to do on the platform, on the pipeline, you can build your own connectors utilizing AWS's SDKs, and it's available for you. And then last but not the least, marketplace connectors. These are connectors that our 3P partners have built so that you can utilize them and connect to multiple 3P sources that are available out there. Managed catalogs. These are fascinating because utilizing managed catalog, you can manage catalog utilizing Amazon S3 or Redshift managed storage to create Apache Iceberg tables directly. What that allows you is the modern open for table format, accessibility directly on your platform. Asset transaction, time travel, all of these neat features available to you at your fingertips. And last but not the least, reliable and secure. Encryption at rest, encryption at transit, IAM-based access control so that your authentication and authorization happens seamlessly, and all the data sits in your VPC control so that the data doesn't leave your private network. So this is what AWS Glue connectors have to do. Now let's see how Alex can utilize everything that we talked about to actually solve his first use case that we said. Alex wants to enrich and unify his customer profiles. Now he is using two key systems. In SAP, he has his operational data, which has purchase history, payment terms, credit limits, etc. In Salesforce, he has his customer profile. So all the sales data, all the sales transaction, the tickets that were opened by the customer, etc., etc. What you are able to do over here, what Alex is able to do over here is utilizing AWS's Glue connector, connect Salesforce to AWS Glue, and the connector takes care of all the Salesforce API integration. He doesn't have to worry about pagination or anything of that sort. The Glue connector takes care of the entire overhead associated with it. Same thing for SAP. Just plug in the SAP connector and plug it into Glue, and that's about it. All the API level transaction that needs to happen, that's going to be taken care by the connector. You don't need to learn a net new API for these 3P solutions on your own. So that's that. Now the best part about it is utilizing AWS Glue, Alex can look for anomalies. Is this the right email address format? Are these the right ages? Does it look fake or not? Are these the right amount? Do I have any negative sales amount associated with it? Why is this important? This is important because you can catch anomalies in your pipeline before they even reach your analytics platform, right? So fewer surprises down the road, making the life of all the other user personas that are going to use this data much, much easier. Finally, Alex can use AWS Glue to aggregate and join all of this data together to create a unified portfolio. And then that data is available on Amazon S3 as Iceberg tables, so that it could be queried by any analytics platform or it's available for any AI ML application. This entire pipeline is serverless, scalable, pay-as-you-go model. And we are constantly making this better. Let me show you how. Right now, we have 60 plus connectors just to 3P solutions, right? So we are talking about Salesforce, Zandex, SAP, ServiceNow, Google Ads, and on and on and on, wherein we take care of all the connectivity platform for you. We are making it better. Just in the last quarter, we added 20 new connections. Just to call out few over here, Datadog. Think about it. You can use your application monitoring data and see how does that apply to my business utilization. You have Okta integration. How is my user interaction? How long are my users interacting with my application? And does that influence the sales that I'm doing within my platform? Adobe Analytics, all the top of the funnel marketing activities that we are doing, how are they influencing our sales? And last but not the least, Asana. How is it that my organization operates? How do we project manage? Which projects are actually moving the needle for my organization? All of this available to you at your fingertips. All of these new connectors are run with standard industry authentication methods such as OAuth 2.0, so that you don't have to worry about storing credentials in files or anything of that sort. Everything is automated in the system, accessible for you. It just works securely and reliably. With these connectors, customers can test the connection, validate the connection, and then browse the metadata as needed. And so to close off this journey, let me tell you about a customer use case. Wire Medical. They are a respiratory care company headquartered in suburban Chicago. They deliver respiratory care products to hospitals and healthcare providers worldwide. It's like any other healthcare company, they had a same challenge. All of their operational data sitting in silos in multiple places. They have data sitting in SAP, JD Edwards, ServiceNow, Salesforce, etc., etc. They need to be able to get all of these disparate data sources together so that they can understand their customers better. They can do inventory management better. They can do their sales management better. How are they able to do that? What they did was they utilized AWS Glue and AWS's Glue connectors to pull in all of these disparate data sources together and point them to AWS's Lakehouse architecture. Over the period of 8 months, they were able to transform hundreds of jobs, ETL jobs, from their legacy ETL tool into AWS Glue. And they had huge benefits. We are talking about 50% cost savings compared to their previous solution. Now that's not something easy. That's a fundamental difference with respect to their cost structure. Imagine the savings over there. But the key thing was actually improving the developer productivity for their data engineering team. These data engineers who used to take weeks to create net new pipelines are able to create it in days. Previously, to get net new analysis, which used to take days, it takes at the best hours for them, right? This is the kind of fundamental operational and productivity change that AWS Glue was able to deliver it for our customers and which we can do for you. So, we have discussed Alex's first challenge, building ETL pipeline. But don't forget about it. He has 2 other challenges that we discussed, right? So for that, I'm going to call my colleague, Shreya Malpani, who's going to come here and talk to us about how Alex can solve that. Shreya?
Thanks, Shruti. So, using the AWS Glue connectors, Alex was now able to simplify his ETL pipelines. Now, his next goal is to keep his analytical data in sync with operational databases without adding much of an operational overhead on his head. His current ETL pipelines run on an hourly basis, so any data that he gets access to in his analytical systems are at least an hour old. He's also responsible to maintain the pipelines and ensure the reliability of them. Now, just like all of us, he hates getting paged at 2 a.m. in the morning because something broke in his data pipeline. So he's thinking to himself, I need a solution that can keep my analytics data current without having to implement complex change data systems which bring in the additional overhead. And this is where AWS zero-ETL can help Alex. Before we dive into what AWS zero-ETL is, let's look at the typical requirements that will be needed if you are running your own data replication and ingestion shops. You might have data stored in multiple sources and may need to apply certain business logics which are specific to each of those sources. You might also need to implement some complex retry logics to ensure that the pipeline does not break because of some transient errors. You would also be responsible to maintain the infrastructure and monitor the pipeline to ensure everything is running smoothly. Plus, you'll also need some specialized ETL skill sets to make sure that the pipelines are running in the most optimal manner. At AWS, we understand that all of these requirements can make the task of replicating data from multiple sources for the simplest of use cases very complex. And hence, we are investing in a zero-ETL future. AWS zero-ETL is a set of AWS-managed integrations that allow you to ingest data from multiple data sources without having to build an ETL pipeline. You can ingest data from multiple transactional, operational, and enterprise SaaS application sources. With zero-ETL, you can get access to fresher data for your analytics, AI/ML applications, or reporting use cases. Now, you may be thinking that AWS already offers multiple ways in which you can operate your data pipelines and ingest data in your analytics, data warehouses, and data lakes. Like we discussed earlier, you could use Glue ETL to build and maintain your own ETL pipeline. You could use Visual ETL to get a no-code, low-code interface, or we offer other services as well where you can operate your ETL pipelines. So, what is so special about zero-ETL? Well, zero-ETL is a purpose-built AWS-managed capability that helps you operate and ingest data from multiple sources in a simple and secure way, where you just have to create the integration once, and then we take care of the rest. It's also highly performant and delivers data from multiple sources to your target systems within near real-time lag. So, say you have zero-ETL integrations from Amazon Aurora or Amazon RDS to Amazon Redshift, any changes on the source will be replicated to the target within a few seconds. And for other sources, these changes can be captured within minutes. What this means is it reduces your time to insight. Zero-ETL is also very efficient, and it runs with minimum disruptions at source. And finally, it has the right mechanisms in place so that you can trust zero-ETL to replicate data accurately to the target systems. You could leverage encryption mechanisms. You could operate the zero-ETL integrations in your VPC systems and ensure the security of your data. Now, many of you and other AWS customers have shared feedback with us that you want your end users of the data warehouses and data lakes to be able to ingest data from multiple sources and use them in the analytics engine of your choice. These end users may not always be data engineers. They could be data analysts who lack the specialized skill sets that are needed to build and operate data pipelines. With zero-ETL, our goal is to enable these end users with a no-code and managed capability so that ingesting data from multiple sources becomes a transformational experience for them. Now, let's take a look under the hood and see how zero-ETL works. We'll look at an example where, say, you have to ingest data from an Amazon Aurora database to an Amazon Redshift database. You might want to capture the initial snapshot of data from Aurora into the Redshift database, and then periodically capture any changes that are made into Aurora and have them reflected in the Redshift database. In this case, Aurora becomes your source and Redshift is your target. Once you set up a zero-ETL integrations between Aurora and Redshift, it starts with an initial load of the full snapshot of the data. So it creates the table on the destination Redshift database and creates the corresponding data types to match the source without you having to write a single line of code. After the initial load is done, it starts capturing any inserts, updates, or deletes in near real time and reflects them in the target database, Amazon Redshift in this case. So if a new record is added to your Aurora table, zero-ETL will add the same record in the Redshift database as well. In case you dropped a column, the same will be reflected on the target database in near real time. That is the simplicity with which you can operate zero-ETL. You just create the zero-ETL integration once, and then we take care of the rest. Let's look at a demo which will show you how simple it is to create zero-ETL integrations. In this case, we'll create a zero-ETL integration from Salesforce to Redshift. A prerequisite for setting up this integration would be for you to create an AWS Glue connection to Salesforce, just like Shruti mentioned earlier. So you could navigate to the AWS Glue console, click on zero-ETL tab, create a zero-ETL integration, select Salesforce as source, click Next, select the right connection, provide the IAM role that has access to the Salesforce data, and then you can start filtering on the multiple Salesforce objects that are available. This is very helpful when you don't want to replicate all of the data from Salesforce, but want to limit it to the specific objects that are relevant for your use cases. Once you have made all the selections, you have the capability to preview the data as well. This gives you an opportunity to check everything looks as it should, before it's too late in the system. Now that the source is configured, you provide the target details. In this case, that would be the Amazon Redshift data warehouse. Now that the source and target are set, click Next, and you can now configure the integration. You could provide the encryption keys or modify the replication intervals for change data capture. You could also add the integration name. Let's say we call it Salesforce integration in this case, and click Next. Review all the details, and finally, if everything looks good, click on Create. It'll take a minute or so to set everything up. And notice how in this case, it prompts us that we have not yet created the Redshift database where the replication should happen. So just with a click here, without navigating to a different console, you can create that database. Let's say we call that database as Salesforce DB. Click on OK, and it's all set. If you go to the Redshift console, you can see that the zero-ETL integration is now active. The new database that we created is also active. And you can quickly start querying that data in the Redshift query editor. So if you look at the databases that you have access to, you would notice that it shows the Salesforce DB database that we just created. And it has 4 different tables, each one corresponding to one object that you selected while configuring the source. Start writing your queries and get the results. You could also dive into the integration metrics and look at the data that has been transferred because of this integration. You could also check the status of each of the tables individually and figure out if any step is needed to debug any errors that might have come up. Such is the simplicity of setting up zero-ETL, and just within a few clicks, without writing a single line of code, you can start ingesting data from multiple sources into the analytical systems of your choice. So now that we understand how to create zero-ETL integrations, let's look at what are the different sources that you can ingest data from using zero-ETL. This year, we have added support for 11 new sources for zero-ETL integrations, and now zero-ETL supports 23 distinct data sources. These can be classified into 3 broad categories. The first one is AWS databases. You can create point-to-point integrations from different Amazon databases like Amazon DynamoDB, RDS for MySQL, and Amazon Aurora. In addition, earlier this year, we added support for RDS for Oracle, RDS for PostgreSQL, and Oracle database at AWS for zero-ETL integrations. The next category is third-party enterprise applications. You can create managed data ingestion using zero-ETL from 8 different SaaS applications, including Salesforce, SAP, ServiceNow, and Zendesk. And finally, last week, we launched a whole new category of zero-ETL integrations from self-managed databases. So you can create zero-ETL integrations from MySQL databases, PostgreSQL, SQL Server, and Oracle databases, which are either hosted on premises or on EC2 instances. So that's 8 additional sources. If you're creating zero-ETL integrations to Amazon Redshift, you can ingest data from all of these 23 different sources. Alternatively, if you want to ingest data in your data lakes in Amazon S3, you can do so from 12 of these 23 sources. You can create integrations from Amazon DynamoDB, and earlier this year, we also launched support for RDS for MySQL and Amazon Aurora databases to create zero-ETL integrations into Amazon S3. In addition, you can also ingest data from the SaaS applications that we discussed about earlier. Now, another thing in addition to the different sources that we launched this year is a whole new target, Amazon S3 tables. For those of you who don't know, Amazon S3 tables provide S3 storage that is optimized for analytics workloads. It has features that are designed to continuously improve performance on tabular data, and it is ideal for storing tabular data, which may include transactional information, your sensor data that are being stored in tabular format, or other forms of tabular data. You could ingest data into Amazon S3 tables using zero-ETL from Amazon DynamoDB or the 8 enterprise applications. So now that we understand the scope of zero-ETL, let's go back to our friend Alex and evaluate his situation. The sales team in his organization is trying to understand what is the revenue coming from some of the top opportunities that were identified earlier. Now, the revenue or sales data is stored in Amazon Aurora, and the opportunity information is available in Salesforce. The sales and marketing teams want to build a customer lifecycle model using data from both these sources and also create reports on some of their top accounts. So the task for Alex is to integrate data from these sources so that the marketing team is able to achieve both these outcomes. Now, Alex thinks that he can build an ETL pipeline to achieve this outcome. He could take a streaming approach, just like the one shown at the top of the screen, and start ingesting that data. Or he could build a pipeline that looks like the one shown at the bottom and have a batch integration approach. But his existing pipelines are already taking up most of his time. So he does not want to add an additional burden of managing these new pipelines. He turns to zero-ETL instead. He sets up a zero-ETL integration from Aurora to Redshift, and then another one from Salesforce to Redshift with just a few clicks like we discussed earlier. And just like that, in a matter of minutes, the data from these two sources automatically starts flowing into Amazon Redshift. And this is available in near real time for any of the analytics needs for the marketing teams. For Alex, zero-ETL means eliminating an entire category of pipeline maintenance work. AWS takes care of the replication of any schema translation and error handling. And Alex can now invest more of his time into business-critical tasks. So Alex was able to achieve 2 of his outcomes now. Before we move to his third task, let's look at what are the other new things apart from the sources and targets that we discussed about that we have launched in zero-ETL. The first category is features that provide you more control when creating zero-ETL integrations. We've added support for on-demand ingestion using zero-ETL for cases where you want to ingest full snapshot of data immediately. We have also added support for history mode for zero-ETL integrations into Amazon Redshift, which preserves the history of any changes made at your source within the Amazon Redshift databases. This allows you to track and analyze any changes in Redshift itself, rather than having to go to the source to track those changes. Second, we added features for more flexibility when you are creating zero-ETL integrations. You can now customize the refresh interval when creating zero-ETL integrations from SaaS sources between 15 minutes to 6 days. You can also create up to 5 integrations from an Amazon Aurora cluster to your Amazon Redshift data warehouse. And this could be to the same or different data warehouses. You can also now ingest data from Amazon Aurora PostgreSQL tables that have declarative partitions. And finally, we improved observability for zero-ETL integrations and started logging the client errors into Amazon CloudWatch logs. This will help improve the debuggability of zero-ETL integrations. As we wrap up zero-ETL, let's take a look at a case study of one of our customers, Pinex. Pinex is a crypto exchange and wants to use the latest market data to deliver insights to their end users. It is critical to deliver these insights on the latest data so that their users can make decisions based on the latest data available. Earlier, Pinex used to operate an ETL pipeline managed by themselves, which led to a lag of 30 minutes. This meant that any insights that were delivered to their users was on 30-minute-old market data. And this was a key blocker for them to deliver the best experience for their end users. They shifted to zero-ETL, and since that shift, they have seen 98% reduction in latencies, 80% reduction in maintenance costs, and 66% reduction in overall operational overhead costs. Such is the impact that zero-ETL can have on your workloads as well. In the words of Senior Director of Data and Analytics of Pinex, zero-ETL has helped them achieve real-time access to their operational data, something that was not possible before. So, now that we understand the benefits that zero-ETL can deliver for our use cases, let's go back to Alex's tasks. He has simplified his data pipelines using connectors. He has eliminated a lot of his operational overhead using zero-ETL. And just as he gets his pipelines running smoothly, he realizes there is a whole different category of requests that he received that he has not addressed yet. These are typically ad hoc requests that come from his leadership, and more often than not, they are required in a matter of hours. Now, Alex wonders in those scenarios that there's just no time to build a new data pipeline. How can he deliver those analysis and insights in the timeline that has been requested? This is where federated queries can come to Alex's rescue. Federated queries provide on-demand access to data from multiple different data sources into a single query without having to move a single byte of data. With federated queries, there is no need to build an ETL pipeline at all. You can analyze data directly where it lives and write a single SQL query which accesses data across multiple sources. We offer federated queries in both Amazon Redshift and Amazon Athena, giving you flexibility to choose the right querying engine based on your use case. You can query and analyze data stored in relational, non-relational, object, or any custom data sources and write a single query to get near real-time insights from the different data sources where your data might be located. This approach works perfectly for ad hoc analysis, for data exploration, for cases where you might have sensitive data which cannot be replicated at multiple locations, or scenarios where you're trying to optimize your storage footprint without having to store multiple copies of the same data. Let's see what all can you achieve using federated queries. Today, we support 30 plus federated connectors, and you can connect to transactional databases, say MySQL or PostgreSQL databases, and AWS databases like Aurora and RDS. You could connect to other storage systems and data warehouses and data lakes like Amazon S3, Redshift, and Snowflake. You could also connect to multi-cloud systems like Google Cloud Platform or Microsoft Azure. You could choose to connect to enterprise applications like SAP or any big data platforms like Cloudera. Let's take a look at how it works under the hood. Say you want to use Amazon Athena as your centralized querying engine, and your data is stored at some of those places that we discussed in the last slide. You can use Lambda-based connectors available in Athena, which will use Lambda functions to access data across these different data sources. So you could either query or process the data from these data sources. You could read the schema or get the records themselves and modify them to achieve the desired analysis that you want. Once the analysis is received from the federated query, you could decide to generate an ad hoc report, create a visualization, or store the output persistently in your data lakes. And that way, you are not copying the whole of your data, but only the analysis that has been generated from the query. Let's take a look at setting up Amazon Athena federated queries using SageMaker Unified Studio. If you go to SageMaker Unified Studio, go to the Data tab, and in your lakehouse, click Add to add a new data source. You can select, okay, sorry for that. You can select the data sources and provide the name and provide the credentials that will be required to access the data in BigQuery. You can also do the same for other sources and evaluate the data or preview the data from a single source. You could also go to the SageMaker Unified Studio query editor and join data across multiple data sources that are available in your lakehouse. This will result into the analytical outcomes that you want to achieve within a minute without really have to replicating the data into your analytical systems. Now that we have set up federated queries, let's see Alex's situation. Alex has recently received an email from his VP of sales, and the ask is that they want to understand the customer tickets that are raised by their top customers. To do that, Alex needs to join data from Amazon Redshift, which has the customer size information, Amazon RDS, which has all the customer orders, and SAP, where all the customer service tickets are located. Alex writes a single query to integrate data across these three different sources using Amazon Athena federated query and gets the output within minutes. He can then store the output in Amazon S3 or visualize it using Amazon Quick Suite. And just like that, he has the output that the VP wanted. So in this manner, he was able to achieve the ability to say yes to any ad hoc requests, rather than having to explain why it will take days or weeks to build a new ETL pipeline and replicate the data. Now let's take a look at what is new with federated queries this year. Earlier this year, we launched support for OAuth authentication mode for Snowflake connections. This mode uses authorization tokens and refreshes the tokens automatically which makes it perfect for long-running federated queries. With federated queries, you can also leverage the multiple performance enhancements that we have introduced to our querying engines. This includes enhancing the querying speed for common file formats, generating outputs quickly when the query results are more than 100 MBs, and expanded DDL support for iceberg tables and S3 tables. And finally, we also launched managed query result storage, which allows you to store the outputs from your federated queries in an AWS managed storage for up to 24 hours free of cost. So, given that we have looked at all the three approaches that we started off with, let's quickly wrap up and understand how these approaches can deliver value. Let's take a look at Alex's situation again. By leveraging these connectivity approaches offered by AWS strategically, Alex was able to transform his data architecture. Complex custom pipelines have now been replaced with AWS Glue data pipelines that leverage AWS Glue connectors, and that provides him control as well as pre-built functionality. Critical operational data now flows automatically using zero-ETL integrations and minimize Alex's operational overhead and maintenance work. And any ad hoc requests are handled through federated queries, minimizing the need to build new data pipelines. For Alex, this means that he now spends much less time dealing with data connectivity issues and focuses his attention on business-critical insights. Just like Alex, you don't have to choose just one approach. The most effective data strategies combine all these three approaches together. When you need complete control over your data pipeline, you can use AWS Glue connectors for self-managed data ingestion. When you want to focus on insights and not infrastructure, you can leverage AWS zero-ETL integrations for a managed data ingestion experience. And when speed and flexibility are key, you can leverage federated queries for in-place data analytics. I encourage you all to pick just one use case and apply these strategies. You could start with creating a Glue ETL job using connectors. You could start with creating your first zero-ETL integration or writing your first federated query. If you want to learn more about any of these topics that we approached today, you can refer to these resources. The first QR code will direct you to a blog that will help you get started with creating zero-ETL integrations. And the second one here will take you to a demo to set up federated queries in Amazon Athena. In addition, you can refer to the AWS Developers Guide to learn more about any of the features that we discussed today. You could also visit AWS Skill Builder to leverage the abundant learning resources available there and even practice with hands-on exercises. With that, I would like to thank you for being such a great audience. Please take time to share your feedback on the session using your mobile apps. Shruti and I will be available right outside this area to answer any questions that you may have. And given some of the other sessions are still ongoing and they're silent sessions, I'd request you to be mindful of them while moving out. I wish you have a great reInvent ahead. Thank you.